Greetings and welcome back to the lab. Now is the moment that I have been waiting for. We're going to build the Redtronome. I've got a whole bunch of parts here ready to go. I've got some figures that I've copied down. I will put those numbers in the description below, and I will also put notes if I have to change some of these numbers. But basically what I'm going to do is go through and build the first oscillator, maybe with some time lapse in there so it doesn't take too long for you to see what's involved. And then I'll come back periodically after I build more oscillators and demonstrate more and more of the capability as I build it. So let's just get cranking on this. First thing I'm going to need, my numbers here for the first oscillator. For the 1/3 oscillator, which means 1 beat every 3 seconds, I need about 34K plus the 1.5. So I'm basically going to look and see if I've got a 33K resistor, and then we'll go from there. If not, I may have to pick something else. And when you look at the numbers I've got posted in the description, you should be able to see, compare that to your stock of resistors and try and figure out how you want to do it. There's a 47. Do I have a 33? I do have a 33. So let's grab a 33. We'll get to some of these other components. I want to build as much as I can from the ground up, so to speak, the smallest or the lowest profile components first. Actually, now that I think of it, I think what I want to do first is add in, and I was going to show you, I have little bags left over from various different things, and so I have, for each one of these, let me find the 1/3, there's the 1/3. I kept the resistor and capacitor that I was using when I was breadboarding it to make sure that I'm using the same components against the numbers that I've written down. So I will be using those. So I need that resistor actually. I'm going to need this resistor. But actually what I want to do is get... now that I think of it, I need to find the actual oscillator chips. But what I want to do is put the sockets on. So let me get to putting those on, and I think I can do that without them getting in the way of anything else. And what I'm also going to do at the same time, basically I'm just going to populate the top of the board here. I'm not going to put all the chips in yet, but I'm going to populate the top of the board with the chips and the power connectors and the audio connectors. So let's get that cranking. I'm going to go into time lapse here, and I'll meet you on the other side. Okay, so now we are into the actual components. So I'm going to take R1 from here. And now that I think of it, there is one component that I had not considered, and I'm going to have to figure that one out. So the previous episode covered almost everything, but that's the thing you're going to kind of learn when you're building some of these things. So let's see. R1 is going to go in here. I do want to do my resistors first. I should say my through hole. No, I should say my 1/4 watt resistors, not my potentiometers. Although, actually, those are low profile. So let me get this one soldered on. That takes us to the 33K that we discussed, hopefully just a moment ago in this video. Let's get one of these out. It should get me in the ballpark of what I need, which was You know what? I've got the numbers in the description and in the description of the previous video showing what the grand total was. So now this 33K is actually R2A. I've got R2 split up in 3 pieces, actually potentially 4, depending on how you look at it, or 3.5. So the first one is just a set resistor. It's not a variable resistor. That is R2A. There will also be a B and a C. But I'm going to get A in here now. And in case you're wondering, just below this resistor and just above the next resistor are test points that I put on the circuit board. So if something does go wrong or if I need to verify the total resistance, I can. So let me go ahead and get this one soldered on. As I do these offcuts, I'll just point out that I actually do have this. I've done enough of these little projects that I have collected a lot of these, and I used to throw them out, but at some point I'm going to be able to take these, and there's a magnet. You can see they are iron based, at least most of them are, so I should be able to actually send these off to recycling and be somewhat environmentally conscious, he says as he tries to get all of them back off his magnet. Alright, that's got that one. So that takes care of that. Now I did want to point out I've got 2 resistor positions right here on the circuit board. I will put up a rendering and zoom in so you can see a little better. But on these 2 positions, these are actually the same resistor. They're wired up in parallel. If you want, you can put the 1/4 watt resistor here and put a potentiometer here, a trim pot, and then they would be in parallel. So you'd have to do the calculation to figure out what that ends up meaning in terms of the actual resistance there. But for this particular application, I'm just going to be using the trim pot. So I've got, that was R2A, this is R2B, this is R2C. This is the coarse and this is the fine tuning. So now, since I'm in the neighborhood of 34, 35 and a half, between 35 and 36K. I've got 33K, which may not be exactly 33K, but I can put in, let's say, a 5K resistor here, 5K trim pot, and then maybe like a 100 ohm trim pot here. That'll give me some really fine control over the oscillator. So that's what I'm going to do, is go ahead and put those 2 in now. And let me go grab them, and I'll put them in. Quick tip, if you're as clumsy as I am and you manage to drop things in the wrong bin, you want to double check to make sure that you've actually got what you intended. So this is a 101, this is going to go on the bottom, and this is a 502, which is a 5K. So I'm going to drop that in this position here. It should fit. This is the first time actually testing this particular profile on a circuit board. I'm relying on the author of that particular profile. Okay, yeah, actually that is, I guess that's about right. That looks reasonable to me. Now I still have to put in a couple of other things. One, I've got to put in the actual capacitor. Oops, there's a stray. There we go. I've got to put in the capacitor. This is an electrolytic capacitor. It is actually polarized, meaning it does matter which direction you put it in. I got to put that in, but before I do that, I got to put in a mix resistor, and I can't remember what I did before. So what I'm going to do, I think, is put a 100 ohm resistor in there. What the mix resistor does is help basically isolate each oscillator from the others. Now it's also going to reduce the power of the output slightly. If I really needed the output, the raw output, it would be up here, but this audio connector is after that mix resistor. So you got a choice. You can either put a 0 ohm resistor in there or a jumper, or you can put some other value in. So I'm going to shoot for about 100. This metronome is going to have its own characteristics. These 100 ohm resistors are not all going to be exactly the same, but I'm going to go ahead and do that. And that should get me pretty close to being able to plug in a chip and see if this thing actually oscillates. And then once it oscillates, I can see if I can get it to oscillate at the right frequency. So this bag is now done. So let me go get a 100 ohm and I'm going to put it in there and I'll be right back. Okay, 2 more components. I forgot one. Oh, actually 3 more components. So I'm going to have to go find a capacitor. Actually, I know exactly where I can find one, because I used it in testing on the circuit board, on the breadboard. So this is I believe this is a 0.1 microfarad capacitor. This is for decoupling. It's just to keep outside interference from messing with our oscillator. So I'm going to stick that in there. And we'll solder this one in too. We're getting there, folks. I'll be right back. Something I forgot to mention when I was working on the last component here, this resistor, is just how close these pads for the adjacent resistors in the next oscillator are. So you want to be careful when you're soldering, or you'll end up filling up these holes. If you only want the one oscillator, that's totally fine. It's not going to affect anything, but you do want to be careful so you don't have to clear those holes before you can stick in the next components. Or when you're building this, if you know all your components in advance, which is hard to do, you want to go ahead and put all of these in going across and then just solder them all in at once. That way you don't have to worry about filling the wrong hole. So that leaves us with the electrolytic capacitor, which in this particular case is a 100 microfarad capacitor. And I want to make sure I get the polarity right. And so for that, the positive is on this side and the negative is on this side. It's the same actually all the way across. It's always positive on the left, negative on the right. So let me get this piece in and we'll be right back. And one more little tip for you. I've got test points right here and here. That's a test point to verify that the switch is actually flipped. And that is a test point for R1. So for the beginning of R1, the other test points down here I will define in another document. It's really just there if I need them for testing. And if you run into problems and you need to troubleshoot, there will be a document on my website where I put the circuit board design up for download, and also I have a 3D file. I'm working on a case for this, and we'll see if that works out. If it does, then I'll post that. Once I get it right, I'll post that. I don't want to post something that doesn't work. So that leaves us now with 2 components. I know I keep adding components as I go, but I just keep realizing that I've missed something. I need to put a switch on here. And the problem with the switch is going to be that it's going to be hard to populate the rest of this board once that switch is in there, but I'm not going to worry too much about that right now. We'll see if there's a better... The problem is if I try to leave all the switches out in order to populate this entire board before I put the switches in, then I would have to figure out a way to jumper over the switch to make sure the oscillator is running in order to test it and tune it. So this switch basically turns the oscillator on and off. I'm going to go ahead and add that in here. Please fit. There we go. Nice tight fit. Well, mostly tight fit. So what I'm going to end up doing with this one, in case you haven't kind of figured out what I'm doing on some of these, is you solder one part of it and then you make sure it's seated properly before you solder the rest. So I'm only going to solder one leg of this switch. And also I am using a lighted magnifying glass right now, which is why you're seeing extra light. You see, that's all wonky right now, which is exactly why I do that. So now the beauty is there's some solder there that I can use, and when I straighten this out, make sure it's seated properly, and then let the solder cool, and it's still wonky. So I've got to figure out how to get that to work right. That look reasonably straight? It could still be straighter. So we're going to keep trying. I'm not going for absolute perfection here, but I do want my switches to line up because there is another board that sits on top of this which captures the nut and the washer for this so that it actually holds it together as a sandwich and actually works as part of the case. So I do want to get it reasonably straight so it'll fit in. Now that's got one of them. Now I can go after the other two. Alright, now I should have it fully connected. Actually, this last one here, closer to the bottom of the board, isn't really connected to anything, but I do solder it in because it gives additional mechanical support to the switch. So now I can flip this switch. Oh wow, that's tight. I can flip the switch. Oh, I should be able to. There we go. That wasn't too convincing. I might have a problem here. Alright folks, I'm going to go away and come back and tell you what I found out. Alright, here's the switch. I've taken it out. It does not appear to want to move. And my fear is that what's happening is when I'm soldering it on, I am melting something on the inside, which doesn't make a whole lot of sense. More likely what's happening is this plastic is a little bit too heat sensitive and is gumming up the parts on the inside. Maybe what I'll do, go ahead and put in the comments down below. I'll put this off to the side. You know what? In fact, I'm going to put this in the 1/3 bag that I'm not using anymore. And if you want me to do a post-mortem and tear apart the switch to see if I can figure out what went wrong, go ahead and say so in the comments down below. And we'll see if we can figure out what happened there. Meanwhile, what I'm going to do is turn my soldering iron down a bit. I've had it up for a while because it was working that much better for me, but I knew that there were some components that were that much more sensitive. So I'm going to try with another switch here. This one flips back and forth with no problem. So I'm going to take off the extra hardware here for now, put it in the bag, and I'm going to try and get this thing mounted. I'll spare you the details, and I'll be back when I'm done. Alright, we got that working. It involved removing the old one. Well, I think I've already showed you that. The new one, though, does indeed switch back and forth, so that's a relief. And I've got now my audio chips ready to go. My oscillators, these are 556 oscillators. This one is unused, so we'll hope and pray that it actually functions. I don't think it's really going to be a problem. I'm just kind of joking around here. But that's always a possibility. Is you get a dud and you go plug it into your circuit and you think you've done something wrong and it turns out to be the chip or something unexpected. So that's got that covered. Now we need an audio connector, and we're going to need a speaker to connect it to. There's an audio connector. I bought an 8-pack of those. I'll get that plugged in. I've got a little powered speaker that is a knockoff of something else. Well, let's see if we can't power this puppy up.
Bluetooth mode.
Yeah, we know. Well, okay, maybe you didn't know. I've not actually tested this out, so here's one more potential variable. But I'm going to try and plug this in, and hopefully it'll tell me. Auxiliary input, I'm guessing is what that meant. That's got that part done. Now we need power. And where did I put my power connector? Somewhere around here. Forgive me, I was excited. I brought everything out. I want to get this working just as much as I'm sure you do. Or I hope you do. There we go. One USB to barrel jack. I probably have more than one of these, and I think I do have more than one of these. But it's brand spanking new. I guess that makes it another variable. But that allows me to plug it in. Oh, that was nice. And I got my power bank, which I built in another episode. I'll put right up here. Built from an old laptop battery. Let's see if we can't plug this one in. Got to get it right side up. We got something happening. Oh my, I think that's actually a... Yes. That's an oscillator. It works. Alright, now the fun comes when we try to tune it. And I got to get my oscillator test set up, which is basically just Audacity with all of these pre-programmed. This is supposed to be the 1/3 oscillator. So let me solo that. Why am I not hearing anything now? It could be it's such low power that my battery bank is shut off. Okay, well, you know what? This speaker also happens to be a battery bank. So let's see if we can do two at once. That's good. Let's hope that keeps running. Now I'm going to get the test pulse going. Well, it's not very loud, is it? If I can turn up my test pulse. Wow. That's pretty close to start with. Could I be that lucky? Very close. Right on time. Slightly off, but we gotta go every 2. Yep. Almost right on time. That is surprising. If you're worried about it being slightly out of time and then coming back into time, remember that a cycle involves, the way we're designing this, and if you look at the previous video, it's doing 3 ticks. You've got the tick to start the wave, the tick in the middle of the wave as it's transitioning, and then the tick at the end of the wave. So when you hear the 3 ticks, if that middle one doesn't line up, but the 2 outer ones do, then it's just the duty cycle is off, and there's not a whole lot I can do with that in this design, but it should be close enough that for most things, and that's, like I said, it's going to be a characteristic of this particular Redtronome oscillator thing that I've put together.